is that you can't retrieve it, and it's prohibited by international law. So, and the status of that is it's under study by only 10 countries. Another method would be space disposal. That's when you send it up into space around the solar orbit beyond Earth's gravity. And the problem with that is if it explodes or anything goes wrong up in the air, then it could contaminate almost the entire world. So that status has been abandoned. Another one would be transmutation, and that process is convert waste to shorter-lived isotopes. And the problem with that is it's uncertain whether waste stream would be reduced, and it's very expensive. So the status of that is under active study by the United States, Japan, Soviet Union, and France. This was a short video, but I can't figure out sound on this TV, so I'll probably email it to you. Types of radiation. So I think there's 4 or 5 types of radiation. The first one is alpha, and its sources would be from fission and fission products. Its penetrating power is very small, and it can only travel in air about 5 centimeters. And shielding material is just, you need to pick it up with something other than your hands. This mode of radiation is beta. Its sources are fission products, and activation products. Its penetrating power again is small, but not as small as alpha. The distance it can travel in air is about 300 centimeters at 1 MeV, which is mega electron volt. And its shielding material will be water, plastic, and wood. The next one is gamma, and its sources would be fission products, and again activation products. Its penetration power is very large, so it's considered very dangerous. It does not travel in air, but to handle it you need lead, plastic, or paraffin. Another one is neutron, and its sources are just fission. Again, its penetration power is very large. It cannot travel in the air, and again, for shielding material wise, you need water, plastic, or paraffin. So this is a list of radioactive decay. It shows like the different types of nuclei and how long it takes for them, just their half-life before they can decay. Just a few of them are, like, say, uranium-238. It takes 4.47 billion years for it to decay. And then there's like thorium, the next one. Thorium-234 only takes about 24 days. A couple other ones that take quite a while would be uranium-234, which is 245,000 years. And then another small one would be, bismuth-210, which takes 5.01 days. So it's a range of long to very short, depending on your elements. So a couple of nuclear deposit problems is that there is no permanent depository for high nuclear waste that has been established. And of the 440 power plants in the world, each yield about 30 tons of high-level waste. So that means the world high-level nuclear waste reaches about 50,000 tons annually. So in 1988, the U.S. proposed a license permit for high-level nuclear waste dumping site, 1,200 feet under the Yucca Mountain in Nevada. It was going to be used for the 110 operating nuclear power plants and for them to dump their waste. The Department of Energy has made little progress and said the site will not be even ready to run until at least 2017. But the problems with the Yucca Mountain is that the Department of Energy did not follow Nevada procedures and did not receive proper state authorization to even dump there. Nevada never wanted that to happen in their state anyways. The popular fight was not in my backyard. The site was based on political considerations and not exactly on scientific situations, so there was a lot of problems. There's also an active volcano about 7 miles away, and there was 32 active faults on the actual site itself, so it could be a little dangerous if anything went wrong. Through the faults, contamination water could escape. Water could seep in and then seep out and get into the mainstream, which would cause contamination to the environment as well as the people. The site is also one of the most mineralized areas on the continent, and 2 of North America's largest gold mines are only 15 to 20 miles away from it. So with like about 2 years of planning have progressed for the site, but there are still many technical issues that need to be resolved. And some of those technical problems are that the site holds about 70,000 tons of high-level waste, but it would take 28 years just to fill that up, and that would have workers working constantly. And by the end of those 28 years, even if we did fill it up, there would be tens of thousands of more waste that we would need to put there, but there would be no room already. So it's kind of like a win-lose situation, kind of. So, and there's also a transportation problem. Trucks will be arriving in like 90-minute intervals, so there will always be constantly trucks full of waste on or coming to and going from the site, which can cause safety and transportation issues. So moving on to that, you heard about all the issues that could happen. Now here are some major nuclear accidents that have happened. First, starting in the United States. In 1951, in Detroit, an accident in research reactor, overheating of fissionable material because of exceeding temperature and caused them not a meltdown, but a little contamination. The air was contaminated with radioactive gases. In 1961, steam explosion at an experimental reactor. 3 people died during that. 1979, one of the bigger ones was the 3 Mile Island. The core meltdown was due to a loss of cooling. Radioactive gases leached in the atmosphere, and 172,000 cubic feet of liquid radioactive waste leaked into the Susquehanna River. Population had to be evacuated from all the vicinity of the disaster. A few that happened in the Soviet Union. 1957, a nuclear reaction occurred in spent fuel, causing a release of radioactivity. Population was also evacuated, and topsoil was moved, and all the livestock was killed. In 1974, in Soviet Union, the former Soviet Union, a rupture in loop number 1 reactor due to boiling of the water. Again, 3 people were killed. In 1975, partial destruction of the core number 1. About 1.5 million curies of radioactive gases released into the environment. Some more from the United States. In 1979, in Irving, Texas, 100 people received a radiation dose of 6 times larger than the normal amount permissible, and it was due to the discharge of a highly enriched uranium. In 1985, New York City, there was 2 nuclear power stations that had a leakage of several hundred gallons of radioactive water, and some of that got into the environment. 1986, an explosion of a tank containing radioactive gas at a uranium enrichment plant caused the death of 1 and 8 injured. In the Soviet Union, though, in 1982, explosions of the generator number 1 reactor, the turbine, was completely burnt to the ground. In 1985, during the startup activities, a relief valve burst in reactor number 1 again. 14 people died due to the errors made by an inexperienced staff. And then in 1986, everybody knows Chernobyl. There was 2 large explosions that blew apart Unit 4 of the nuclear power plant. It released 50 to 250 million curies into the atmosphere. And to put that in perspective, an atomic bomb that was dropped on Japan only released about 1 million curies into the atmosphere. So this was at least 50 times greater than that. The accident killed 31 people right off the bat, and then the Soviets later admitted that it killed 224 other people. It was the worst nuclear disaster to this date. This is the top 10 list of nuclear reactors. You can see the United States has the most, the 104, all the way down to India with only 14. United States produces 99,210 megawatts, and India at the number 10 spot only produces 2,550. You see France, Japan, Russia, United Kingdom, South Korea, Germany, Canada, and Ukraine are all in there too. So nuclear energy is not what it seems to be. It looks like to most people, it looks like it's a low cost of power, and it can produce a large amount of energy, but in the long run, it will cause immortal radioactive contamination to the environment. It produces, again, large amounts of nuclear waste. Again, it's limited to technical options for storage and disposal. We still haven't figured out exactly how we're going to dispose with everything. And that's becoming a huge problem. We're getting more buildup of raw materials that we have no idea what to do with, and in the future this could cause huge problems, and it could just start destroying valuable pieces of land. And major accidents are always bound to happen, especially with everything I just listed off. There's always so many errors that could go wrong, either technical, mechanical, and even human errors. You just don't know with this because we just don't have the technology that we need to be putting into this. So with that being said, there's always a possibility of contaminating our environment along with everybody around it. So when looking at this, you got to understand, like, nuclear power puts out a great amount of energy, but the risk is just, it's almost too high to keep it going unless more research is put into it. That is my presentation, and thank you.